answer. Okay, so based on yesterday, we said all this stuff equals this stuff, right? And basically, we're replacing the opposite with y, the hypotenuse with r, the adjacent with x. And then we have 6 trig functions. Sine is so. Sine of theta is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. And then cosecant is a reciprocal of sine, so that becomes the hypotenuse over the opposite. Secant is the reciprocal of cosine, so that becomes the adjacent over the hypotenuse over the adjacent. And then cotangent is the adjacent over the opposite. So we're just flipping these ratios. And so we're asked to find all 6 of those ratios for this one problem. Before I could do that, I got to figure out what r is. So if we do the Pythagorean theorem, and I'm going to write a lot of extra stuff, and I'm going to zoom in because I might need to go to another slide. So to get this right, I need to do x squared plus y squared equals r squared. Right? That's just the Pythagorean theorem, right? A squared plus b squared equals c squared. But we're replacing it with x, y, and r. So they tell us that x is equal to a, and y is equal to 1/3 of a. Okay. So when I plug that in, I'm going to get a squared, right? I'm just plugging in an a wherever there's an x, plus 1/3 a squared. And I'm going to zoom in a little tighter here so that way I can write small and we'll have space. Okay. All right. That equals r squared. Remember, r squared is what we're solving. So a squared is just a squared. But on a side note, and I'll write this down kind of small over here, I'm going to say that 1/3 a squared is the same as 1/3 a times 1/3 a, right? So when I rearrange this and I say 1/3 times 1/3 times a, this whole thing becomes 1/9 a squared. And this is just a squared. Okay. Now I'm going to need to take the square root at some point because I need to take the square root of this to get r. But I want to combine these two terms and see if I can. Okay. Well, right now, this is the same as, think in your head, what do I do if I have 2 r, well, let's not use r, let's say 2t plus t, right? When I add those up, I'm really just adding the coefficients. I don't have a 1 in the front, but it's there. So that just becomes 3t. Here's the thing, though. I have 1a squared, right? So that's that coefficient. And then I have 1/9. So that's that coefficient of a squared. So I'm going to add 1 plus 1/9. So I'm going to rewrite it like this. 1 plus 1/9 times a squared. Okay? And all of that has to equal r squared. Well, I can't just add 1 to 1/9. I have to have a common denominator, right? So in order to do that, what I can do is change the 1 to 9/9 plus 1/9 times a squared equals r squared. So when I add that up, I get 10 over 9a squared equals r squared. Now at this point, I'm going to need to take the square root of both sides. And I'm going to pause there and give you guys a chance to write that down if you haven't already written it down. I'm adding more steps so you can see. I think I skipped 1 or 2 steps when we did it yesterday. I think that's what kind of caused some confusion. We need to put our cell phones away, though, and write this down. Your notes are for a grade. Okay, so now what do? All right, so if I take the square root of both sides, and I'll start writing over here because I ran out of room, r is equal to the square root of 10 over 9a squared. Now, part of the challenge with this is I have to simplify this. It makes my life a little easier if I can simplify this. Well, I know that 2 squared equals 4 and 3 squared equals 9. I have a 9 right here. So that means I can pull it out of the square root. So how do I do all this? Well, one way to do it is I could think in terms of this. I could say r is equal to the square root of 10 over the square root of 9 times the square root of a squared. That's a legitimate move for square roots. In other words, because I have a 10 times a squared, which is divided by 9, I can separate all those into individual square roots. If there was a plus or minus sign somewhere in there, I could not. But because they're all either factors or multiples, because we're multiplying, that's a property of square roots I could do. I could take the product of a square root and separate it into the factors. Okay? So now when I do that, here's the thing. 10, the square root of 10 cannot be simplified. But the square root of 9 is just 3. And when you take the square root of a square, you're just left with the base, which is a. Okay? Now that's a lot of work, and we haven't even answered the first of 6 trig functions. And there's more work to do. So we did all that work so that I could write up here, the radius is the square root of 10 over 3 times a. That is what you're learning. That's what I have to teach you. That's the new stuff. But it's really old stuff, right? You guys have learned at some point in time how to do the square roots. You guys have learned about fractions at some point in time. But it's a lot to have it all together in one problem. Okay? So now what do? Well, now that we have r, I simply plug in. So we said that sine, right? We said that sine of theta, and I'm going to make this a little smaller because we're going to need the room. We know that sine of theta is equal to the opposite over the hypotenuse, right? Because we have so, ca, toa. I don't know why I put a lowercase. That's going to mess with somebody's head if I don't fix that. Okay? So its sine is the opposite over the hypotenuse, but we said that the opposite, based on our photo here, based on our image, is y, and the hypotenuse is r. So we're going to say, well, in terms of a point on the xy plane, that's the same as y over r. So what's the y value? Well, the y value is 1/3 times a. That's y. All over r. Well, what's r? Uh-oh. The square root of 10 over 3 times a. All right? Now, if I have a over a, right, what's anything divided by itself? 1, right? So a divided by a reduces down to 1. In other words, a divided by a equals 1. So 1 times this stuff is just 1/3 all over the square root of 10 over 3. Well, this is the same as 1/3 divided by the square root of 10 over 3. So whenever we divide by a fraction, right, we multiply by the reciprocal, right? So the first fraction stays the same, and then we multiply by the reciprocal, right? So this whole thing becomes 1/3 times 3 over the square root of 10. Now here's an interesting thing. In a roundabout way, I have 3 divided by 3. What's 3 divided by 3? Well, it's just 1, right? Just 1. So then if I multiply across the top, I get 1 times 1, which is 1, all over the square root of 10. Okay? But we cannot leave the square root in the denominator of a fraction. We can't do it. We just can't. That's one of the rules. You can't have 0 in the bottom of a fraction, and you can't leave a square root in the bottom of a fraction. So to get rid of the square root, I do what's known as rationalize the denominator. I multiply by the square root. But remember, when you multiply by something, whatever you do on the bottom, you do to the top. Okay? So this is the square root of 10 on the top. And technically, what's 10 times 10? Well, yeah, it ends up being 10, but what's 10 times 10? 100. What's the square root of 100? 10. So whenever you square a square root, you're left with the base. So this is sine the square root of 10 over 10. I'm going to make that a little cleaner so you guys, there's no questioning what it actually is. Okay? That's a lot of math. But it's all one little thing, and it's very meticulous. Okay? Now guess what? Let's do cosine. Well, cosine is the adjacent over the hypotenuse, right? So I'm going to say cosine of theta is the adjacent over the hypotenuse, and that is going to be x over r, right? Because if I go over here and I look, well, what's the adjacent? Well, the adjacent measurement from here to here is whatever number I have for x, right? So if x was 5, the length from here to here would be that value of x. And then we did the math to get the radius. So now, what is my x value? Well, just a divided by the radius. Well, what's the radius? The square root of 10 all over 3 times a. The nice thing about this, sort of, is that a divided by a is just 1. So this becomes 1 over the square root of 10 divided by 3. Again, we're dividing by a fraction, so I'm going to say 1, but can I rewrite 1 as 1 over 1? Yeah. So I'm going to say 1 over 1 divided by this fraction is the same as 1 over 1 multiplied by this fraction. When I multiply across the top, I get 3. When I multiply across the bottom, I get the square root of 10. we cannot leave a square root in the bottom of a fraction. So I rationalize the denominator. Whatever I do on the bottom, I have to do to the top. 3 times the square root of 10 is the exact value. I leave it that way. Can I plug it in the calculator and get a decimal? Oh, yeah. But we want the exact value. So we leave it that way. And then the square root of 10 times the square root of 10 is just 10. Okay? All right. So now, let's do tangent. Tangent is going to be the opposite over the adjacent, or y over x. So my y value is 1/3 a all over a, right? Am I getting that right? 1/3 a all over a. So again, a divided by a is just 1. 1/3 divided by 1, this is just 1/3. Well, that was pretty easy. Whew. Right? All right, what's the reciprocal of sine? Which is it? Some say secant, some say cosecant. So this is the hard part. We want to say cosecant is cosine because co, but it's really cosecant, right? So cosecant of theta is actually the reciprocal of sine. In other words, it's going to be the hypotenuse over the opposite, which is going to be the radius over y. Now, this is an interesting phenomenon that I've seen since COVID when it comes to schoolwork. Let's say you didn't know that off the top of your head, and we're just talking, right? You're just guessing, we're just talking. But what could you do when you're doing your homework and you don't really know for sure? You could guess, but one of the things that I'm noticing is you guys put your notes away, right? Right here is where it is. So when you do your homework, if you don't know, you just look it up in your notes. You just turn the page and look at it. But the thing that I find fascinating, not everybody does this. Most of the kids use their notes. But the learning process is you got to see it 27 times. And sometimes you can see it without me having to write it out, okay? So just remember to look at the notes. If you're not 100% sure, look in the notes, okay? So anyways, let me zoom in here. So now here's an interesting thing. I know what r is and I know what y is, but I know what the simplified version is. Isn't it this? Right? If I carry this all the way out, isn't it this? But I reciprocate that, right? The simplified version is going to be 10 over the square root of 10. Right? Can I leave that square root of 10 in the denominator? How do I get rid of it? I'm going to multiply by the square root of 10 across the top and bottom. So then I get 10 root 10 all over 10. My 10s will cancel. This 10 cancels with this one. It just becomes 1 over 1. And so this is just the square root of 10. Okay? How do we feel? Let me get a pulse. How do you guys feel about it after we kind of go over it? So here's the thing. We just have to keep going over it. It's not hard, but it's a lot of steps. And then knowing what step to do, that's the challenging part, right? So what's the reciprocal of cosine? Secant. So this is going to be the reciprocal of this stuff which is going to be the hypotenuse over the adjacent, which is going to be x over, oops, I messed up. It's r over x, right? So we say r over x. But I know what that looks like. It's going to end up looking like this, but the other way around. Technically, this is what it is, isn't it? And then we do the rationalizing of the denominator and all that stuff. Can I just reciprocate that? Okay, there's some people looking at me like, I don't know, Mr. Adams. Well, we'll just do this one. It's extra practice. So we'll say, oh wait, I did it wrong. I'm going to reciprocate this one on the end here, and I'm going to say 10 over 3 times the square root of 10. Can I leave that square root of 10 in the bottom? Nope. So I'm going to do the square root of 10. And so I get 10, the square root of 10, over 3 times 10. Now I'm going to pause and let you guys write that down and just process that. You guys see where that's coming from? Ten divided by 10 is 1. 1 times the square root of 10 is 10, root 10, and then 3 times 1 is just 3. So when I said, isn't it this? We could have just reciprocated that. Remember, this was the answer, right? But we had to do this extra math stuff. And then lastly, cotangent is the adjacent over the opposite, which is x over y. And we know it's the square root of 10, right? Or no, it's 1/3, right? This is tangent, right? So what's the reciprocal of that? 3 over 1. And that's basically it. Now, this is the first time that you've seen this. Let me zoom out a little bit here. That's a lot of work for one problem, isn't it? So I could see when you look at that, go, whoa. But that's why this is a pre-calculus class. There is no other way to get the answer. But if we do this a couple times, and get closer to that 27 mark, it's actually kind of easy because you're really just taking the square root, doing well, it's everything that you've learned up until this point in one problem, right? Like you have the XY plane graphing something, right? You have geometry, which is the triangle stuff. Then you have really like pre-algebra concepts like adding fractions and square roots. But then the new part is just remembering the ratios, and then it's everything all in one problem. Okay. Do you guys have any questions on this one? All right.